This screencast is going to investigate the Pythagorean theorem. There we go. So basically the Pythagorean theorem is used in right triangles, and again, as we know that a right triangle is a triangle with a 90-degree angle, and it allows us to find the lengths of sides. So again, here we go. Applies only to right triangles. There. And it allows us to find the missing sides of a right triangle. So if we draw a right triangle, and let me make sure I'm on the pen, draw it like this, and then we can label, usually we like to label it as A, B, C. So the angles take on the capital letter, while the sides will take on the lowercase letter. So the side opposite angle, right angle C, would be lowercase c, the side opposite angle A would be lowercase a, and the side opposite angle B would be lowercase b. And many of you, or a few of you anyways, may have seen this equation already, but the Pythagorean theorem is a squared plus b squared equals c squared. And it again, it has to do with sides A, B, and C. Sides A and B would be considered the legs, leg of the right triangle, and C would be considered the hypotenuse. So there you have it. The Pythagorean theorem is a squared plus b squared equals c squared. And now we can investigate how we will apply this theorem to finding the sides of a right triangle. So here we have example 1. Right triangle, ABC, where A and B again are the legs of the triangle and C represents the hypotenuse. And again, we can relabel. So 13 would stand for the lowercase c, and the 5 would stand for the lowercase a. And guess which side we're missing? That's right, side B. So we want to find side B. All right, and we can apply our Pythagorean theorem, which once again states that a squared plus b squared equals c squared. So with that said, you just substitute in. So we know A is 5, so we can write in 5 squared, plus B squared we're looking for, equals C squared. Now for some of you, these are common squares. So 5 times 5 is 25, plus B squared is equal to 13 times 13, may be a little bit more difficult, but that is 169. And then we are trying to get B by itself. So we move, this is just an algebra equation now. We're moving 25 over to the right, and we're left with B squared is equal to 144. Well, to get rid of the square, we must take the square root of both sides. And when we square 144, we get B is equal to 12. So we found side B, which equals 12. And quickly to check here, we can go back to our Pythagorean theorem formula and substitute in to make sure we're correct. So again, for A, we ended up with, let me make a little space here, we ended up with 5 squared, plus B was 12 squared equals 13 squared. So 5 squared being 25, 12 squared being 144, and 13 squared being 169. And if you add 144 and 25, you get 169, which equals 169. So the check would show that we have all the sides of this right triangle correct. We'll move on and try example 2. So example 2, this is a little bit different. We don't have this triangle labeled ABC, and you'll find as you do more of these problems, you're not going to have the triangle labeled the same way every time. So you got to improvise a little bit. So first of all, notice that the side we're looking for is the hypotenuse, which is this lowercase x, which means that the angle opposite that, the right angle, could be capital letter X. All right? And then you could label the sides and the angles any way you want. Let's try y. So y for this angle, capital Y, would mean that the side opposite would be lowercase y. And then let's call this angle z, and the side opposite would be lowercase z. So in this case, a squared plus b squared equals c squared, which is our Pythagorean theorem, can now become x squared plus y, strike that, y squared plus z squared equals x squared. And I almost made a mistake there because, again, x is the hypotenuse here, so your legs are y and z, and your hypotenuse is x. Just like with a squared plus b squared equals c squared, as we showed you earlier, a and b are the legs of the right triangle, and c is the hypotenuse. Now we can at least attempt to fill in. We know what z is. Z is equal to 4. Y, we don't know yet, or it's not easily observed. And x, we don't know. We've been asked to find it. So if we've been asked to find x, then it is assumed that we probably know what y is. But that takes a little bit more of a careful investigation here. Because if you look at the triangle, you'll notice these hash marks. So the hash mark here and the hash mark here. And as we learned earlier in the chapter, what that suggests is that side xy is equal to the length of side xz. Therefore, this triangle is an isosceles triangle. If you have an isosceles triangle, you know that side z equals side y. And again, isosceles triangle. So we can cross out the question mark here, and we now know that y is equal to 4. We can now solve for x. Y squared would be 4 squared, plus z squared would be 4 squared, is equal to x squared. And then that would leave us with 16 plus 16 equals x squared. Mosey over here, and we get 32 equals x squared. Now we want to get x by itself, so we can take the square root of both sides, and we can get x is equal to the square root of 32. We won't talk about simplifying this just yet, but we do have an answer, and x is equal to the square root of 32. In example 3 and example 4, you are going to go through and try to figure these problems out on your own. Give it a good shot. Best of luck, and enjoy. It's now time for Try These. So if you haven't been patient with yourself and taking your time to get through the screencast, you probably won't be able to solve these problems. And if you haven't been watching this screencast at all, then you won't realize that there are some embedded questions, which probably, if you're a teacher assigned the screencast, will expect you to have answered them. In any event, here they are. Example 3 and example 4. Best of luck and enjoy. So here's example 3. You have triangle ABC and you're asked to find side B. Get after it. Be careful here on example 4. You're going to have to go and label the triangle. And again, we're asking you to find the missing length. So you have to figure out which length is missing. Again, use the Pythagorean theorem and make sure you label your triangle correctly. Good luck.